So, gentlemen, the work is on the board. 2, 4, 6, 7. How many do we usually get?
Well, it's still break time.
All right. Well, just so you guys know, you can start this now. Okay. I need you to finish off the array loop. Make sure you do it in pseudocode and Pascal. Okay. Change the array type from integer to string. Easy enough. And loop through the array with a while loop instead. Now that'll be a bit of a different change to things.
Thirteen or 12, I think.
Someone also needs to. No one bothers to fix it.
Doesn't look like that to me.
No, I thought that first. I want to change the last one.
Oh yeah, if you want to do it.
All right, gentlemen, let's log in. Let's get this Pascal going. I want to see some for loops. You guys are so far ahead compared to doing for loops and if loops. You're doing so much better than you students. Just start.
There was a friend in the class that used to
Okay, you're Alright, gentlemen who just arrived, there's work on the board. Finishing off your for loop. Okay. Your array loop. And then you've got to change that array from an integer to a string.
Yep.
Okay, and then we'll work on while loops.
Let's write this in pseudo.
Guys, listen to me just for a second.
No. Well, I've been told that I'm not here.
Gentlemen, back corner. Alright. Guys, can I just have an idea of where you are at in terms of why you would use an array? Like, what sort of real life examples would you use an array for? Yeah, no, you're right. Why? Like, can you think of a real life, I don't know, robotic example, a computer example? Like, this isn't just a matter of, hey, let's enter some numbers into an array. Can you think of a reason why you would ever want to do this? Like, it's not just that you're in this classroom and you've been told, hey guys, let's learn Pascal, let's learn what an array is, because it's an array, and let's do it. Okay, that's stupid. You need to know, at least have some idea of why you do this. Anyone got an idea? Any real life example? No. It's cool if you can think of something or not. I just thought I'd give a couple of examples of signal processing stuff that we do in first and second year uni, how we use arrays. Have you done 2D arrays yet? No, okay, so we'll start with 1D arrays. Okay? I can't draw on any of these boards. Okay, guys, so in the computer world, everything is digital. And what it means by digital is everything has individual values. It's not continuous. So temperature in itself, as an example, is a continuous measure. Temperature can be anywhere from 0 to, let's just say it can be anywhere from 0 to 100 degrees. Okay? It can be elsewhere, I know, but if you were to take a measurement, you'd be able to say, okay, that's 10 degrees. Okay, it's cold. But you could also say it's 10.0001 degrees, or 10.000001 degrees. Like, you can go down to an infinite level of discrimination, how small that number, or how accurate that number is. In the digital world, we don't have that possibility. But listen, in the digital world, we're restricted to a certain number of numbers because of how big our computer is. There's memory, there's bits, there's bytes, there's integers. Okay? An integer is how big? How big is the biggest integer? No. In computing terms, how big is the biggest integer? The biggest single number? No. Okay. Now you guys don't know this, but an integer, so you guys haven't learned this yet, but I'll let you know. An integer is made of 16 bits. Now, maybe you guys have done this. Okay? So a bit is either 0 or 1. Okay? So an integer can only go from the value 0 through to 2 to the power of 16. You can't actually... So what's 2 to the power of 16, anyone? I forget. Doesn't matter. It's a big number. Okay? It's a big number. But it's not infinite. Now, you're restricted because of this to how many values you can actually have. So if we were to measure temperature between 0 and 100 degrees, if this was all the numbers we could possibly use, we can't break it down into an infinite number of temperatures. We have to choose which temperatures we measure. And that could be, maybe we only choose to measure, guys listening, maybe we only choose to measure every degree. So So maybe we only measure 0, 1, 2, 3, 4. If the real temperature is if the real temperature is 10.32796 off to infinity, we still say the temperature is 10. Does that make sense? So in computing, things are digitized.
Hey, it's just the wrong thing.
Wow. Okay, so in computing, things are digitized, and they have a particular and we have to choose a particular number. And this is where arrays come in. Now, I'm going to give you an example that we did. Does everyone know what they're doing today? I'm going to rub this off. I'll give it to you later. Okay. In engineering and very much in computing, you do a thing called signal processing. You take a signal in, and you need to measure or find something in it. So in first years and second year university courses in mechatronics, we do a heart rate monitor. We actually build, I don't know if I talked to you guys about this last week, I talked about it to you as well. You build pads, you stick them on your arms, you plug it into a computer through particular processing, you read the electrical signal, and it releases. Okay? And what comes in is a heartbeat signal, which looks like that. Okay? Now that is the continuous, that's what's actually the electrical signal across your wrist at a particular time. Okay, you've all seen that in movies and all that sort of thing, like the ECG monitors in hospitals and stuff like that, right? But when you read it into your computer, you actually have to choose what values you're reading. Okay? So the values you actually get out are discrete. And so if we were to look at this, it would be something like, when we read it, we read these values. Okay? So you're getting, you've got sort of a zero value, and then you're getting these numbers going up. Okay? And we convert it into values, we put it into an array. Because it's all about numbers. So our array of this, okay, is a really long array of different numbers of our measurements. So let's go with all this. You might have 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 1, minus 4, minus 7, minus 6, minus 1, 0, 2, 1, 0, 0, 0, 0. Okay? And they're the readings of my heartbeat. So here's an example, a real-world example of how we're turning something that's in real life, we're reading it into our computer in digital numbers, we're storing it into an array. Okay, now that we have the data in an array, we can start doing stuff to it. And one of the ways that they do it, like one of the ways that my students go about it, is they just go, they do it. So once they've stored it, using some sort of while loop or a for loop, for the value 0 to 100, reading number, store number, store number, store number, store number, store number, store number. Then they come back and they read the data and they go, if array I is greater than 7, let's say greater than 5, then, pseudocode, run heartbeat. So what they're doing is they're saying, we're going to do a check. And if my signal has gone above 5, the electrical signal of 5 at any time, then I'm going to say there's a heartbeat. I'm going to store that. Is this making sense? Yeah. So this allows us to do a whole heap of stuff. Now this is just one example. But being able to store data in big arrays gives us so much freedom what to do and how to do things. Okay? This is real world signal processing. So in this case, if the array is greater than 5, it just goes along. No. Yes, heartbeat detected. And then the next thing is run the heartbeat detection, which is like make the machine beep. So it's beep, beep, beep. Right? Then you can do other things. You can store how often that happens. You can start calculating the heart rate. You can start doing all other sorts of calculations. But there's a cool little example. So when you're doing this sort of stuff, don't be afraid to ask why. Okay, it's not just because it's computing and arrays store data. How would you use this to actually do a real-world problem? Okay, there's heaps of things. Like think about it whenever you're running a computer program. How am I storing this data? Like, is this data being stored in an array somewhere? It probably is. Yeah. Another example is here's a good one, and I'm going to relate it to computer games. Okay, here's a good one. Okay. So have you heard about the hack? Like you guys have played Skyrim, right? Yeah, I love Skyrim, so I just use it all the time. Have you heard about the hacks where people basically just they program the computer, like they run a raid, or not a raid, they run a mining project like to an ore pit or something, and then run back home, do all the smelting and all that sort of stuff, and then go over and over and over and just do it over and over. And what they do is they set up the bot, so they run it, and they set up the bot to actually just do those controls over and over, so that this thing they can just go to bed. This thing will spend days and days or weeks and weeks doing the same thing over and over, just build up massive experience in smithing or something like that, right? And then it runs happy. Okay. What they're actually doing in doing this is making an array of positions. Okay, so let's say X and Y. So we've got a map of Skyrim. This is home, this is the mine. Okay, but to get there, there's a big mountain in the way, and this guy has to sort of go along paths and all the way to there, and then it gets there and he does a mine and then he comes back. Okay, but there's a path along the way. You've got X values and Y values on the map. Now, if you want to set up that bot to do this over and over and over and over, you need to store an array of how your character actually moves. Okay, so it just repeats it over and over. You need to store that array. Simple. Okay, X and Y positions. X changes over time. So you store your X position. It might be, south 10, south 9, south 8. And Y is moving as well. So Y is going up. So it is, X is east and west. So maybe west 10, west 8. And then Y starts moving north. So it's gone from south 20 to south 18. To south 15. Okay. So that doesn't relate to this map that I'm just drawing here, but you can see how if this joins up over a really long period of time, then you know exactly where it's gone, and you can just retrace your steps over and over and over and over because you stored that in your array. So here's your array of X values, and here's your array of Y values. That's a good example. Make sense? Yeah. So these things are used all the time in almost any computing process. But whenever you get this sort of stuff, just ask why and how I use it. When you start thinking like this, things become a lot easier. Cool. Any questions? No? All right, let's get to it. So we are doing. First step is we want to finish off the array loop in pseudocode and Pascal. Okay. You've got 10 minutes. Let's do it.
What? He didn't give us his email yet, did he?
Yeah, but I'm not really tomorrow. So.
Might ask him.
But it won't even like load the
Guys, it looks like some people have been unplugging internet cables. If your internet's not working, just check under your. No, have a look. See if it's sitting out. Blue cable. So try plugging it in. That needs to go into the wall. Track with. But if you need, change the computers, please. Any luck? This one. Okay, that sucks. This one. No, this one. Yeah, okay. Have you switched them? Okay.
It's already plugged in, so
I'll switch it.
there's already one plugged in.
Does it work?
I need two of them plugged in. I don't want to do this. It's probably not even going to work.
There's really some really ridiculous like shaman.
Try it. Refresh it.
What?
Let's look it over.
Almost sold out from Sydney. Food or retaliation.
Actually, it's neither.
What?
So I swapped it over and now it's like not working anymore. That one will be working. Yeah, maybe. There we go. like cobwebs now.
That was easy to change into a string.
You're not doing advanced yet. That's food, you can eat that. So,
Yeah, so.
you know what the problem with the internet is?
Are these the alarms? I'm sorry it's late, but I'll get Mr. Lee to take it off now.
What part is this for?
This is the part D.
Okay, so those
Ah.
You have to submit the arrival matrix as well.
maybe try
Oh, we have
the
to.
other two is try swap them.
How are you going in your...
I haven't started part C or D yet.
I've done B, I've almost completed A, I've sort of done B, and I haven't started C.
Is C where we just say what things it uses? Like, it uses the monitor, the keyboard, mouse.
Not mouse.
Actually, you're true, it doesn't use the mouse.
Unless it specifically requires you to click on something, then no, it does not. Compiling it requires the mouse, but the actual running of it.
And it's just the running of it anyway.
So there's monitor,
CPU,
CPU,
RAM, keyboard.
Depends on there's no sound, so
You can't use the sound cards. Or speaker for that matter.
yeah, there's only 4 things. Or with motherboard.
Motherboard's like a component of chip stuff. That's like got the processor, the sound card, the RAM.
Got everything else.
So you can't just say motherboard is part of it.
You a while loop instead of a for loop.
You have. Let's see if my test works. Kyle. 51.
Is it a while doing?
I'm thinking of just leaving the account on my computer on. But then, like, who knows so many other people?
CPU is a rose. Whoops, I forgot to put point.
The one made by Conrad.
That beautiful one.
Is that meant to be thrown?
Yeah, green one. My multi-assignment, my next multi-assignment, apparently you have to make a music video. This will be the video.
What's the music on the video?
Good way of saying this is you, like, Liam singing a song. Oh yeah, that's really realistic. You could definitely do that in real life. Like, I already did that. What do I do if I produce it?
Why don't you let the user decide how many they want? Okay. I was gonna say, because you could have just made another variable, 2 more variables or something. No, you need one.
Talking with your mouth for a little bit.
Semicolon.
The bad.
Me? Why?
Really sad thing about husband.
What the fuck? Okay, that makes more sense now.
What's breaking my code?
What happened? What's it missing?
It won't write the names back out.
Right when name I is equal to I plus 1.
Oh no, is this the one you get black out?
I is equal to 1.
Don't tell me.
And then you plus. That's where you're wrong. Because you're only repeating I once. And then the second one is only going to repeat either the last name you put in.
I's name one character.
Did I give him an 81 then?
I don't understand how people spend like the majority of their time. But I don't understand how people
Math. Character.
I think I know where the problem is. Maybe.
Which game?
I really spent 40 minutes of my life doing off that. 40 minutes of my life.
Blank. Something did happen, but it's blank.
Like there was no commentary. Someone sent it to me and they were like, watch this, and I watched it. And
Amount
I was like, I'm not
I didn't change anything.
What do you mean?
Because you see how I here is equal to 1 and then you're plussing 1 on top. But then when you get to here, I is still equal to the last one you did. It would probably only print like one of them. Then I don't know.
You can't see how far the marker goes.
it's kind of like fine.
Wow.
That thing gets 100% fit with it.
With his honor class. That'd be so hard to play.
The only issue is it's not controlled with blasting or arrow keys, so that'll be annoying.
No, I think it would be good if you could like move. No, it's not terrible. I hate it.
Okay, off with that. Come on.
Okay, get over to Pascal. Doing your 4.
I told you to swap it back, that's what I did. No, we started at Lost Metro and then saved it. But I guess I can run.
Alright, guys, hands up if you've done a for loop. You guys have. Okay, you 4 I need to sort out. How you guys doing? You have? You? There you go.
Get the ladder and then.
Yeah. This is inside when we used to remove the cable from cars. Like standard. Sending lights. Flash black on you. Remember Ash Black? That's it. You remember the old call putting in an app? Yeah. Cable? Yes.
Wait, what are you trying to do?
Pseudocode.
How do you say chill?
Did it work? What was the problem?
Just writing out the wrong thing. So when it was still writing an I, it was the last one.
Oh, yeah?
So when I changed it to when anyone starts another counter, so it would increment 2, increment 3.
Oh, yeah. That makes more sense.
No, that's done. Okay, I should start my assignment now.
That's what I'm doing.
Do you have the assignment sheet here?
Yeah.
Cheers.
I'm not thinking about you. Someone said 21. What was that? What is 9 plus 10? Oh, let's go. That's the question.
Alright guys, we're going to take a quick roll and then we're going to run through the array loop. Okay? Lauren. Guys, quiet. Lawrence. Eleanor.
Yeah.
Louis. Yeah. Jesse. Yeah. Joel. Joel. Lewis.
Hey.
Ellie. Eli.
Yeah.
Sorry?
Yeah.
Lucian.
Yeah.
Colin. Matthew.
Here.
Connor. Connor.
Yeah.
Sydney.
Yeah.
And Ria. Or Nathan. Sorry, Nathan. Okay, guys. Let's look at an array loop. Gents, basically. Let's look at an array loop. I know some of you have done it, but we're going to get through it quickly. Face to the front. Setting messages. Okay. So, guys, what's the first thing we do when we're setting up an array? Sorry? Variables. Okay, so in this case, I'm just going to do my array. Okay, we declare it. Okay, it's an array. So the thing that I'm working on is an array. Okay, and how big? Most of you only go to 4. That I've seen. Okay, but I want to just sort of say that this number can get very, very big. And this is why we actually do this. Why we do for loops. These guys at the back discovered. Okay, but this is the important part. Okay, we'll start with 4 and then we'll see what happens later on. Okay. So what's the next thing that we do? How do we start our code? Begin. Okay, begin. Okay, now we're going to start a for loop. Now, guys, I know there's a few of you who haven't actually even started this yet. Okay, I know there's a few of you that haven't quite started this yet, but we go for a number. Sorry, I need to declare an integer up here. Okay, for I is 1, 2, 4, I'm going to do something. Okay, this is the key. This is how you structure this. Okay, now what this means is that I'm going to now do something. Okay? Okay, so what this means is I'm going to do something. Right? And I'm going to do it with the value of I being equal to 1. And then I'm going to finish that, and then I'm going to come back and do it again with the value of I being equal to 2. Then do it again, the value for I being equal to 3, and then for the value of I being equal to 4. I'm going to do it in a loop. And once I've hit 4, I'm not going to do it anymore, and I'm just going to start the next part of my program. So that's what a for loop does. It just takes a little bit of code, and it does it a bunch of times with one value changing. Okay, so it just loops through things. Now this is really, really good for arrays. Fill up arrays. Because what are arrays? Arrays are a long line of numbers. Okay, or integers. The way I write this is, or the way I think of it, so we've got 1 to 4, but that just means I have 4 empty spots to fill up with numbers. Okay, so in this case, my for loop, I'm going to do, and I'm going to begin, and all I'm going to do is say my array at the position of I is going to be equal to I times 3. Okay, and then I'm going to end. So there's my for loop. Okay. Now, we're going to step through this and see what actually goes on. Okay? We're going to step through this, you two, on what you say. Okay? Now, we're going to step through this and we're just going to see what's going on. We've set up our variables, we've set up our integer, okay, and we begin. Now, for I equals 1 to 4, we're going to do. The very first step is I equals 1. I equals 1. So what's going to happen? My array at position 1. Now, this is what I'm talking about here. We've got my array, we set it up, there's 4 values, and they're all unfilled at the moment. But now, I'm talking about this guy here. At position 1, my array at position 1 is going to be equal to I times 3. And what's the current value of I? 1. So what value is going to go in here? 3. Easy. Okay? Now, the next thing, and then we end. And we're done. So then we come back up and we go again. For I equals, well, we've done 1, so what's the next value? 2. Easy, right? So my array at position 2 here is going to be equal to I times 3. What's that? 6. Right? So we're done. We go again. For I equals 3, position 3, I times 3, we've got 9. Go again. I at position 4, 4 times 3 is 12. We just started our 3 times tables, if we wanted to. Okay? We could go on forever. And in fact, this is a really easy, like, you can imagine this as a 3 times table lookup. Okay, so if we did this, and instead of up to the value 4, we went to the value 4 million, okay, whatever value I've got there, yeah, 4 million, okay, and I filled this up all the way till 4 million, okay, I now have an array that goes through my 3 times tables all the way 3 times 4 million. And if I wanted a really quick way of looking up exactly what that number was, I could do a read. Is it read? Sorry? Oh, right. How do I do that? Right. ln of what? I forget how to do it. But let's say my array of value 77 as an example. Okay? And what's going to come out is 3 times 77. That's what's going to be printed onto the screen. So I can immediately go, oh, I've got my 3 times tables up to 4 million. And if I ever need to find out exactly what it is, I just look up my array 77. Okay? Not useful when it's 3 times tables, but if it's 17 times tables or 67 times tables, it could actually be a quick, nice, easy lookup. Okay? And it can get a lot more interesting. Like I said, if you start storing heart rate values into this array, it could be kind of cool. But there's your for loop to get an array going. Cool. Try and get it running.
I haven't done pseudo cache.
Is that what that is?
In pseudo, do you need to put your variables?
I don't think you need to define variables in pseudo.
How about your program?
I haven't really tried that. I think it's just begin.
Park caps lock. How the heck do you adjust space?
How do I say all my variables? So you need a new one for your right? That's the
I'm sure that's how you do super.
How you guys going? Really good. I finished my work and I'm doing the assignment for that week.
Yep.
I believe you, Victor.
Thanks. I'll save this. Yep.
Wow, nice. Just give me a quick look at the code. That's lovely. Okay, good. You guys don't need help at all. Okay. For you 12, just things to think about for every time you write code from now on. Just telling you completely about it. Think about how you break it. Okay. And you guys have the clues you are using, or in this case, you are using a string. Okay. It's much harder to break it because you're entering that it was an integer, as an example, and I was to enter a letter. What would happen? Now you can program an error detection method where you go, if not integer, then output to the user not a number. You would loop back around, please re-enter the numbers. So you can start thinking about ways that you'd actually break your code and how you would actually mitigate that happening. Okay? Does that make sense? So if you've got your number, you just give me there's other things you can consider. So you say things like value. So there's actually 4 numbers. So one of the codes I saw, there's a code I saw over there before, was you're just writing back out. They had a question saying, please, which value do you want to read? You know, whether you're reading the third or the first or whatever. And then if you press 5, you broke it because there was only 4 values in the array. It's trying to read outside the array. So you can mitigate that again by checking, but also in your message, being really explicit about what it is. You know what I mean? Like, being really, you guys have actually done it really well, and so this is not a criticism at all, but just pointing out to you, you've done it. Now think about it when you do it. Really consider what's going on. Thanks.
Do you have that sheet? Yeah, I just need to check what's going on. Yeah. Thanks. Oh boy, that's a lot of code. Do you have to put the Pascal into the document too?
You can just have your. I think you can just submit the Pascal file on the USB.
Because I was wondering, because it said print out half of it, and yeah. I'll name and identify intellectual property. Explain features, characteristics, ancestral functions of terminology. Discuss both the positive and negative features based on scenario. Okay. When does the bell go?
As soon as I
Shit, I did this. Okay. What class is this? Next cycle That's the class.
Software, what line do you
Do we have a line? Line 1. That's what I got. Name and define intellectual property and all terminology.
Alright guys, I'm hoping that you all got a for loop working. Okay? Now, can you guys sign out of your computer and I'll talk about a while loop just quickly. Sign out of your computer and pull in close. Pull into a chair.
For a song as well. We'll just do the code.
It's just pseudo. I want to make sure that you get everything, otherwise I could end up in screen designer.
Okay, guys, let's come in. Log out, please. Come in close. Come in close. We're going to talk about the difference in a while loop and a for loop. Ways that I draw it and ways that you think about it. Logging off.
Wow, condition do this. Oh, we start doing out.
Okay, some of you know it. Guys in the back, come in. Guys on the computers, log off. Okay. Ladies and gentlemen. Alright, you guys today have done a for loop. Now, the for loop worked because what it did was it looped around, but it was through a finite number of things. Okay, you knew exactly how many times you were going to go through the loop. You said for I equals 1 to 4, we're going to do this, which meant you're going to do it 4 different times. Okay. Now, the way I guess I'll come back to this. The way the for loop worked was you initialized. Okay, you came down and you ran a thing a number of times until it had done it, and then it jumped out. Okay? So you ran it 4 times. The way that the while loop works is slightly different. Okay? While loops work by testing a condition every single time. Okay? So what it does is you initialize your variables. So in this case, we're going to say I, or our counter, equals 0. And then we have a test. The very first thing is do a test. Wait for it. Okay? And it is I greater than, let's say, 10. Okay? So while I is less than 10, we're going to do something. Okay? Now, if that's the case, then we do our thing, and then we loop around again and test whether the I has changed to the case where it's greater than 10. Okay? And if it's a yes, we go off and we go do something else. But if it's a no, we do it again and again and again until I has changed to be greater than 10 in this case. Okay? So our while test, we never know how often this loop is going to happen. Okay? Make sense? You can restructure your for loop by just having a thing down here where I equals I plus 1. So you're just looping through that value and you're actually implementing it each and every time. Okay, cool. Head off. See you next week.
Again.